Jamie, you are here. Okay. So today we have to do the mean value theorem, which we sort of did with the Katie Harvey's Korean crazy lady. And a quick comment from last week. I didn't do it very well in this class. It went much better in the others. We graphed her average speed, which was 60 miles per hour, and then if we were to graph it like she was starting off, she was clocked here at 42, so that slope is 60, maybe that's 42 or 43, whatever, and she ended at about 43, and it's a continuous function. We have to somehow like connect them. The slope right here, she's a criminal. In half a second, she went like a quarter mile, which is really fast. The other classes, we took snippets of what people graphed, and like, how fast is she going right there? Some kids had her at 120, some had her at 90, but whatever the case, she's definitely doing over 70. So anyway, just that from last week. Mean value theorem is, let's see, if the car averages 55 miles an hour over a 2-hour trip, that it had to have been doing 55 at some point. Does it have to do 55 the whole time? No. But it had to do it at some point in there. And the reason this has to be true is the mean value theorem, which we will write down if you don't have it already. So this is what we had on the end of the investigation last week. So there's two conditions. It has to be continuous over the closed interval, differentiable on the open interval. So to show you what this means, so if this is my function, y equals x to the 2/3. If I'm asking for what coordinate makes the mean value theorem true over this interval, I need to find the average, which is just slope. F of 4. Oh, I did it the wrong way. Let's do it this. 8. F of 8. It's the cubed root of 8 that's then squared. 4. And cubed root of 0 that's then squared is 0. So the average slope is a half. And mean value theorem is saying there's somewhere that this average slope will equal a half. So where does 2/3 x to the 1/3 equal 1/2? So if it's continuous and differentiable, the average is this green line, and the instant is that tangent line. And I chose this specific example to show you at 0, it's closed, like the function's defined there, but the derivative is not, and that doesn't matter, it still holds. So continuous over the closed interval and differentiable over the open interval. They will always ask something about this. Always. And part of the getting the points for doing this, you need to state the conditions. Is it continuous over the closed interval? Yes.
Yeah. Oh, no.
Good?
Okay.
I changed the interval because I wanted it to come out nice numbers in at least one place. The other one, x is 64 over 27. Not so good. Okay. So see if you guys can do mean value theorem for that. And when it says show that, basically it means state it. It's a polynomial, it's continuous. The derivative, Gus, what's the derivative? 2x. So when you find the derivative was also a polynomial and had no funny business, then it's also, you can just declare it. If it's a rational function, meaning stuff is in the denominator that might have caused a 0, you can be like, oh, it's undefined at 3, but I'm looking for 0 to 2, so we're good. Okay, so Luke, what would you do first? There's 2 good choices.
Find the average over that.
Okay, so what is the average? How do we do that?
F of 2 minus f of 0 over 2 minus 0.
So that's 4 minus 0 over 2 minus 0, which is 2. Sasha, what do we do now?
Now we plug it into the equation.
So what is the equation that I'm plugging into? What am I doing? This is my average, and I need to find where does the average equal the instant. So what's the equation I set up?
I'm not sure.
Bradley?
2 plus 2x is 1x.
Okay, where does the instant 2x equal the average that we just found? So when x is 1, so a times, if they were asking for the coordinate, which it's uncertain, usually they just want the x value. What is the coordinate? Because we can find it.
1, 1.
1, 1. So there's the average, there's the actual curve, and the one spot that it works is right there. Can there be more than one spot? Okay. But it's guaranteed to have at least one. know that you need to write this down because you get it. But again, this is the math notation that they say to technically define increasing. If you have two x values, this is an x1 and x2. Oops. And x2 is always further down the line than x1. If the y values as you go further down the line are higher, that's what we call increasing. Basically, if the y values are going up, you're increasing. If the y values are going down, you're decreasing. Like, duh, you know that, right? We can also, like, if you need to give proof for this, if f prime, the derivative, if the slope is positive, that also means increasing. So as justification, where is it increasing? When f prime is positive. When is it decreasing? When f prime is negative. That's the mathematical proof that they're going to ask you for on stuff. This needs to be true. If it's not continuous, you got no guarantees. It could still happen, but it's not guaranteed. And if it's not differentiable, you can't use the derivative as proof. Okay.
Down. That's fine.
Cool. Can we do the derivative for us?
Yeah, it's 6x squared minus 12.
Roxana, how do I answer this question?
I set it equal to 0 to see where it would flip slopes from positive to negative.
And where is that?
I didn't find it. But I guess root 2. Plus or minus root 2.
When you put the square root in, you need to remember plus or minus. If the square root's already there, you take the sign that's written in front of it. It's not written, it's implied to be a positive. Okay. And how we check to see if it's increasing or decreasing, number line. And just a heads up, the number line alone is like a 12-page paper on AP about why that's not enough. So you need to do the number line to do a check, but then you need to say words to interpret the number line. And we are naming the number line with the derivative. So Josh, pick a number this way and tell us what you're checking.
I'll just pick like negative 1,000.
Okay, negative 1,000, what are we plugging it into, the function or the derivative?
X squared minus 2.
Plugging it into the derivative, so it ends up being positive or negative?
Positive.
Positive. Plugging in 0 into the derivative, I get 0 minus 2 times something positive, that's negative, and then 18 million plugged in. So Camden, what is the interval where it's increasing?
Instead of negative, I need the negative root 2 and then u root 2 to n.
Okay, round or square? AP will take either one. Personally, I hate when it's square, but they'll take either one. Because if it's increasing there, it's also decreasing there, and how is it increasing and decreasing at the same time? Kind of bugs me. And it's decreasing, whoops, over those. And then as justification, this is not enough justification. Why is it increasing? Because F prime was positive. This one, why is it decreasing? Because F prime was negative. I'm sorry, those are not supposed to be alphas, they're x's. So you don't need to give lots of words. You can give just the math statement. F prime is greater than 0, increasing. The y values are going up. F prime is less than 0, the y values are going down. But the number line is not enough. Cool?
Oh,
I know, Amir, it's Monday, real Monday.
I ran out of paper in my notebook.
Got it covered?
Yeah,
All right.
that's why I got 2 notebooks.
Okay, this is to make integration easier later. If the derivative is 0, what do you know about the function?
It has a slope identified. No
So-
slope, the slope is 0.
So if the derivative is 0,
It's a constant.
it's a constant. The slope would be 0. So those of you who know integration, well, never mind. But to integrate 0, you get some kind of constant. Might be 0, might be 1, might be negative pi to the third. It'll make more sense in a month. Oops. Okay. Tom, what's the derivative of the y equals 3x minus 5?
3.
Josh, what is the derivative of y equals 3x plus pi squared? Crazy. Preston, what's the derivative of 3x minus 7?
3.
Uh-huh. Jamie, what's the derivative of 3x plus 100?
3.
Okay, so this is saying if the slopes of the two functions are the same over some interval, their only difference is a plus z. Okay, what that means visually, these things were parallel at that point, and they're just a shift of each other. Is that true even if it's not linear? Well, if I have some kind of cosine function, it's also just a vertical shift of each other. The difference is just some constant. This wasn't very much on the mean value theorem, despite the fact that's what they called it, this section. Any questions about
Oh.
telling it like it is? No. We have already done that.
Chapter 4.
Yep, thanks. Comes after 3. This was technically your wild and crazy homework for 4.1. And just want to point out, absolute max on this one is here, absolute min was here, absolute max is there, so the min was in the middle, yeah.
Do you have an absolute minimum or not?
Okay, so that's what I wanted to talk about. This one has an absolute maximum here. There's no minimum at all, not even a local. This one has an absolute max here, because it was closed. What is that guy down
It's
here?
a whole.
It's a hole, but is it a max, a min, or is it a?
It's neither.
It's not either one. This is the absolute minimum. What's this guy?
Local min.
Local minimum. Miriam, what about this? That's closed. This is open. This is closed. This is open. Closed. And that's closed.
There's no absolute max or min.
No absolute max, no absolute min. Are there locals? Sydney, what's the local maximum?
1. Where would we have 1?
0.
The local maximum is 0 at x equals 1. Oddly, the local minimum is also 0 at -1. What's that guy? Jasper. What's that guy? Red? It's not anything. Okay, and this one open here, closed there. Absolute max of 5 at x equals 0. Absolute min, don't have one. Okay. This is today's homework. Let's see if I have all of them up there or not. There was no homework over the weekend. It was the worksheet that we did in class. So there are a few problems missing from there, but that's most of them. If you guys could start, that'd be great. Start sitting again.
Extreme values just mean absolute local maximum.
Extreme values mean highs and lows, yes.
Both absolute.
Yes.
Oh, you are.
Show all the work. I'm not showing all the work. You're crazy if you say that. One beat.
I get it. It doesn't.
What